All right, so today we're going to take a look at an explicit sequence. So an explicit sequence is a rule that's kind of a shortcut to a recursive sequence, because a recursive sequence is generating a list of numbers by applying a rule to a given number over and over again. In other words, you have to go one number at a time, whereas an explicit sequence is a list of numbers generated by applying a rule to a term number. So in other words, I can find any number in the sequence by just applying one rule instead of having to go one number at a time. So for now, let's do what we did yesterday, which is we're going to find a rule. So I'm going to write the question is asking us to find the 8th term of this sequence. So I'm going to have to do that the slow way. So to get from 5 to 8, I can either multiply by 2 and subtract 2, or just add 3, things like that. So I think I'm going to try add 3, and that does work. So let's try adding 3 from 8 to 11. That also works, so that is a reasonable rule for this sequence. So the rule is going to be a1 is 5, where an is equal to the previous term plus 3. So this is the rule for what we're going to call an arithmetic sequence. An arithmetic sequence is a sequence where the rule is to just add the same number over and over again. So our rule is add 3. And that's going to be important for writing an explicit rule. So this is the recursive rule. And soon we're going to write the explicit rule. Let's find the 8th term. So the next term would be 14, that's the 4th term. Then 17, that's the 5th term. Then 20, that's the 6th term. Then the 7th term would be 23, and the 8th term would be 28. So there must be a shortcut to getting here. The shortcut would be that I would start at 5 and add 3 7 times. So my shortcut, or my rule for this problem is really, I can find any number. Let's say I want to find the 7th number. I would start at 5 and add. So if I wanted to find the, let's say the 8th number, I'm going to start at 5. So I'm going to find the 8th number. I'm going to start at 5, and I'm just going to add 3 7 times. And the reason this works is from 5 I have to add 3 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So I'm adding 3 7 times. So that's like a shortcut for this particular sequence. So the general idea, let me change this to blue. So this is the rule for finding the 8th term. But if I wanted to find any term, the rule for finding any term, just going to move this over a little bit, would be to start at my first term, whatever that is, and add the amount I'm adding n minus 1 times. In other words, if I wanted to find the 15th term, I'd have to add 3 14 times to get to the 15th term from the first term. And this is called an arithmetic explicit sequence formula. So you'll notice the recursive rule, I needed to know the first term. I need to know the first term in the explicit rule as well, but it's part of the formula. So this is an arithmetic sequence. In an arithmetic sequence, we add what's called the common difference over and over again. So there's a very specific thing we do there. We just add one number. If the sequence does anything beyond just add or subtract, it's sort of like adding a negative number, it wouldn't be considered an arithmetic sequence. Let's take a look at the second example. The sequence here is 2, 4, 8. So I can add 2 to get 4, but it doesn't work to get to 8. So that means this could not be the possible rule for this sequence. So I'm going to come up with a new rule. I need a rule that gets me from 2 to 4. Let's say times 2. That works. If I multiply by 2 again, will I get 8? I do, which means times 2 is a perfectly acceptable rule for this sequence. So let's write our formula. So b1 equals 2, our first term, and our rule is to find any term in the sequence. I need to know the term that comes before that, and just multiply that by 2. So I'm going to put the 2 in the, I'll put it over here, times 2. So this is my rule. I could probably write this with the 2 in front of the bn minus 1. This is my recursive sequence. Now, when we have a rule that's just multiplied by a number, we call that a geometric sequence. So if we just add, that's a arithmetic sequence. The number we add is called the common difference. And the explicit formula looks like this. In a geometric sequence, we multiply by a certain number. We call this the common ratio. And it also has a shortcut formula. So let's say I want to find the 8th term. Well, I can just keep multiplying. So the 4th term is 16, the 5th term is 32, the 6th term is 64, the 7th term is 128, and the 8th term will be 256. Was there a shortcut to doing this? Yeah, I could just start at 2 and multiply by 2 1, 2, 3, 4, 5, 6, 7 times. So if I want to find the 8th term, instead of starting at the previous term, the 7th term, I could start at the first term, which is 2, and multiply by 2, the common difference, 7 times. So this would be the formula needed to find the 7th term. So yeah, this finds the 7th term, the 8th term, without finding all the terms before it. But the shortcut formula would be any term can be equal to the first term times whatever the common ratio is, n minus 1 times. So similar to how there was an n minus 1 in the arithmetic sequence formula, this is the explicit formula. For a geometric sequence. I need to know where I'm starting. So in this case, if I wanted to find the 100th term, I would need to know my first term, which is 2, and multiply 2 by 2, the common ratio, 99 times. So I start at the 100th term, so I don't need to multiply 1 time. So 99 terms is every time except for 1 more time. And we could say that this formula would work for any term in this sequence. Anyways, so these are the formulas. This is your starting number, or first term. This is our common difference. This is the sequence, but the n itself is just the term number. And n minus 1 is going to be 1 less than the term number. So it's not the previous term, it's just 1 less than the term number. So if the term number was 12, I would plug in 11. I'm not actually subtracting. And the common difference has a formula that says take any term and subtract the term before it to find the common difference. So if I come up with an arithmetic sequence, which is a sequence where I just keep adding, like 10, 8, 6. This rule appears to be minus 2, which just means that the common difference should be negative 2, which I can see by taking any 2 terms in the sequence. So I'm going to take these 2 terms and subtract any term by the term before it. So 8 minus 10 is negative 2. If I chose these 2 terms, I would do 6 minus 8, which is also negative 2. In other words, how did I get to the next term? All right, so the common difference here is negative 2. So the formula for this particular sequence would be an equals the first term, 10, and I would put minus 2 because that's my common difference, times n minus 1. For a geometric sequence, which means I'm multiplying by the same number over and over again, these things have the same meaning. This is just the sequence. but n means the term number. This is the first term. R is the common ratio. And this is just one less than the term number. So an example would be, let's say, 20, then 5, then, so I'm dividing by 4 times 1/4 is my rule here. So 5 times 1/4 is 5/4. On a calculator as a decimal, that would be 1.2. 1.25. So the rule for finding the common ratio is I could take any two numbers and divide them in the order in which I got them in. So if I took 1.25 and 5, if I do 1.25, which is the current term, and divide it by the term that comes before it, that I'll get 5/4 as a simplified fraction, which means I multiplied by 5/4 to get from 5 to 1.25. The same thing would also happen if I did 20 and 5. So if I do 5 divided by 20, I should get 1/4 when I simplify the fraction. Okay, so for this sequence, I started at 20. So the sequence is the an equals 20 times 1/4 times n minus 1. So in order to find the third term, I would have to start at 20 and multiply by 1/4 twice. All right, so what you're going to do for each of these problems is determine if the problem is arithmetic or geometric, and depending on what it is, determine what the common difference or the common ratio is. Then find the 50th term using the formula. If it's arithmetic, find the 8th term if it's geometric. The reason I have a difference in these two numbers is because geometric sequences grow really fast. So if I look at our first problem here, 256, if I asked you to find the 100th term here, it'd be in the billions, and you would never get the answer. Excuse me. So if it's an arithmetic sequence, find the 50th term. If it's a geometric sequence, find the 8th term, and then write the explicit sequence. So let's just pick one of these at random. Let's just pick 4. Well, I'm going to look at these problems. So to get from 10 to 5, I can either subtract 5, or I can multiply by half. So based on those possibilities, I need to see how can I get from 5 to 2.5. Well, 5 minus 5 is not going to be 2.5, so it can't be that. So the rule is times 1/2. So that means this sequence is geometric. Okay, so if I wanted to, I need to find the 8th term. So the 8th term of this sequence would mean I would just keep multiplying by 1/2 over and over again. So I'm going to rewrite 2.5 as 5/2. I'll leave it as a decimal. We'll go with that. So the formula for this sequence will be a of n equals the first term, which was 10, times the common ratio, which was 1/2, that's our multiplier, times n minus 1, or to the n minus 1 power. So if I want to find the 8th term, I would say a8 equals 10 times 1/2 to the 7th power. And this will calculate our values. So I can use a calculator, which I'll pull up now. So it's 10 times 1/2 to the 7th power is 0.078125. I might as well write the whole number. 0.078125. 0.078125. Running out of space over here. But that's all I really want you to do for these problems. So write down the type of sequence it is, identify what the common ratio is, write the formula for it, the explicit formula, and then calculate the 8th or 50th term depending on the problem. All right, hopefully this made sense. If you have any questions, let me know. The homework problems are similar. And